Hi, ladies and gentlemen. Note 7.3 are on arithmetic series. So the first thing we need to do is define what a series even is. So the difference between a sequence and a series is the sum of the terms of a sequence. So for example, I could have a sequence that is 3, 7, 11, 15, so on and so forth. This is my sequence. If I want to find the series of the first four, so the sum of the first four, because that's what series means, the sum of the first four, and this is a finite series because it's not all the terms all together, it's just the sum of the first four terms. Then all I literally would have to do is 3 plus 7 plus 11 plus 15. So that's the difference between series and sequence. But that would get annoying if we had a lot of terms. So we're going to figure out a way to actually find the sum without having to actually add up every single one of my terms. So an arithmetic series is just the sum of the terms of an arithmetic sequence. And this is always going to be finite because the infinite series will always be infinity, okay, for arithmetic. And then for partial sum, it's the sum of the first n terms of a sequence, okay? Okay, so now we're going to find out how to actually find the sum. So for question number 1, you're going to want to write pretty small because we have a lot of information that we have to fit inside of here. But before we write that information inside of here, I just want to remind you, this is for arithmetic. So if we have an arithmetic series, it's always going to be t sub n is equal to t sub 1 plus n minus 1 times d. Okay, remember that's the general term. So if I want to find the sum of a series that looks like this right here, if you notice it's a plus d plus a plus 2d because we keep adding d on every single time. So essentially what's happening here is we're going to add up all of these terms right here. So s sub n means the sum of the first n terms, okay, so sum of the first n terms. I'm going to take my first term, which is a, but here it's just t sub 1. So I'm going to use t sub 1 so we can see how it's going to relate to this explicit formula that we have here, or this general term that we have here. So a would just be t sub 1. That's the first term. The second term, to get the second term, what we're doing is we are literally just going to take t sub 1 and we are going to add d to it. Now I'm purposely spacing this out so that way on the next line we're going to be able to line things up. So leave a little bit of space so that you can see what's happening. And we continue that pattern, right? We're going to add t sub 1. But this time, I'm going to add d twice. So here, I'm going to take t sub 1, add d to it to get this term, and then I would add d again to get the next term. So this would be plus 2d, okay? Plus, I'm going to do this a bunch of times, and then eventually, I'm going to get to a point where I'm going to have my last term. And remember, this right here is going to tell me the formula for my last term. So I want to start, I want to pick up after the dot, 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 on the third to last term right here. So if this is the last term, then 2 terms before that would be n minus 3. So this right here, and I know this is a little bit confusing, so just bear with me. This right here is going to be t sub 1 plus n minus 3 times d, because we're going to multiply, we're going to add d. Here we added d 0 times, here we're adding d 1 time, here we're adding d 2 times. Here, this term right here is the third to last term, so we would add it n minus 3 times, okay? Then I would take the second to last term, so this right here would just say t sub 1 plus, instead of n minus 3, it would be n minus 2 times d. And then finally, we're just going to write down the last term, which is this formula, the general term, t sub 1 plus n minus 1 times d. Now, each one of these colors represents one of the terms in our sequence, and this dot, dot, dot means that there's a bunch of terms in between. I want to bracket off each term. So each color that I have here is going to be within its own set of brackets. So now that I've done that, the next thing I want to do, and you're going to understand eventually why, it's going to be kind of weird at first. And by the way, if you have questions, write them down and let me know if, what they are next time I see you. So the next thing I'm going to do is I'm going to write the sum of the first n terms, but this time I'm going to do it backwards. So I'm going to start with the last term, which we figured out right here was going to be t sub 1 plus n minus 1 times d, plus, then I'm going to take the second to last term, which is t sub 1 plus n minus 2 times d, plus, then I'm going to take the third to last term, which is this one right here, t sub 1 plus n minus 3 times d, okay, plus dot, 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 because it's going to keep on going, plus, now, if I'm working backwards, I'm on my purple term right here, so this is going to be t sub 1 plus 2d, okay? And then I'm going to say plus, underneath this guy right here, I'm going to say t sub 1 plus d. And then underneath the last one right here, I'm going to write plus t sub 1. And what I'm going to do is I'm going to add both of these formulas together. Again, you'll see why in a minute. Just bear with me for right now. So s sub n plus s sub n means I have two s sub n's, okay? So essentially what's going to end up happening right here is, first of all, I'm just going to group these together so you can kind of see what goes together. I'm going to add these guys together, then I'm going to add these ones together, okay? Then these ones will get put together. Then I'm going to add these ones together, okay? And then I will add these ones together right here. And then lastly, I will add these ones together. Okay, so when I do that, what will end up happening is I will end up getting here t sub 1 plus t sub 1 means I have two sets of t sub 1. That's the first term that I have here. Plus n minus 1 times d. Okay, so that's what I get for this first term right here. Plus, over here, when I add these ones together, t sub 1 plus t sub 1 is going to give me 2 t sub 1 plus. Now this is saying that I have one set of d, and then here I'm saying that I have n minus 2 sets of d. So right here, what this is essentially saying is I have 1 plus n minus 2 sets of d, which is n minus 1 sets of d. So this is saying that I have n minus 1 times d. Plus, now I'm going to add what I circled in blue. So t sub 1 plus t sub 1 is still going to be 2 t sub 1 plus. Now here I have two sets of d, and here I have n minus 3 sets of d. So 2 plus n minus 3 would still give me n minus 1. So I have n minus 1 sets of d. Plus, dot, dot, dot. If you notice, it's the same thing inside of here every single time, which is the reason why we started to do things backwards. So then over here, if I do t sub 1 plus t sub 1, that's 2 t sub 1, plus here I have n minus 3 sets of d, and then I'm adding 2 of them on, so I have n minus 1 sets of d. So still, same thing, n minus 1 times d. Okay, plus here, same thing, 2t sub 1 plus, or t sub 1 plus t sub 1 is 2t sub 1. Here I'm taking n minus 2 sets of d, and I'm adding 1 set to it because of this d right here. So plus 1, and sorry, I forgot to put this in brackets before. So this ends up being n minus 1 times d, plus, and then here, lastly, t sub 1 plus t sub 1 is 2t sub 1 plus just this n minus 1 times d. Okay, so if you notice, it's the same thing over and over and over again, which means that this happened n times, because we're this right here was the general term, this is the last term, and it happened n times. So that means that I can say 2 times the sum is equal to n times each one of these terms. So it's going to be n times 2t sub 1 plus n minus 1 times d. Okay? So the next thing I'm going to do is I'm going to divide both sides by 2, because my goal is to figure out what s sub n is. So that means right here that I would end up getting, so I'll just put a little line here so I don't get everything kind of confused with everything. So right here, this means that s sub n is equal to n times 2t sub 1 plus n minus 1 times d all over 2. Okay? So the reason why we did this is because now we have a formula that we can use to figure out what the sum of any series is going to be. Okay, so this is one way we can do it. Now, there's another way that we can do it. So I just want you guys to see this really quickly. If we have the sum of the first n terms is equal to n times, right here we've got 2t sub 1. We can just say t sub 1 plus t sub 1 instead of 2t sub 1, and then I'll just copy the rest of it down, times n minus 1 times d all over 2. Now, if you guys remember right here, this t sub 1 times n minus 1 times d is t sub n, and we have that here. So instead of this, all I need to do is use t sub n. So here, what I'm going to say is I can say s sub n equals n times t sub 1 plus t sub n all over 2. So these are two different formulas that I can use to find the sum, the sum of the first n terms of an arithmetic sequence. So let's just summarize what we have here. So our sum formulas for arithmetic series, one of our options is this one up here. So s sub n is equal to n times 2t sub 1 plus n minus 1 times d all over 2. And we use that if we know what the common difference is. Okay, so we always use this when we know what the common difference is. And then the other one that we have here, the other option we have is that the sum is equal to n times t sub 1 plus t sub n all over 2. And we use that when we know what t sub n is. Okay? All right, so let's apply this question. Number 2, in an amphitheater, seats are arranged in 50 semicircular rows facing a domed stage. The first row contains 23 seats, and each row contains 4 more seats than the previous row. How many seats are in the theater? So essentially, what it's saying is I want to take the first row, which has 23 seats, the second row, which has 4 more seats, or 27 seats, the third row, which has 4 more, so on and so forth, and I know that there are 50 rows, okay? So we're going to do this 50 times. I want to know how many rows there are, or how many seats there are all together. So in order to figure this out, I need to identify what do I know. So I know t sub 1, and I need to know t sub 1 for both equations. By the way, when I said you need to know d and you need to know t sub n, that's in addition to the things that are in common with both of these terms. So you use this if you know d, and you use this if you know t sub n, but you always need to know t sub 1, and you always need to know n. Okay? So we know t sub 1 here is going to be equal to 23. We also know that the common difference is going to be 4. And we know that there are 50 rows, so n is 50. Since we know d, we're going to use our first formula. So we're going to say s sub n is equal to n times 2t sub 1 plus n minus 1 times d all over 2. Now all I have to do is just plug in my information. So here we know that n is 50, so I'm going to do 50 times 2 times t sub 1 we know is 23, so it's going to be 50 times 2 times 23 plus n minus 1. If n is 50, then n minus 1 would be 49, so I'm going to say that this is 49 times d, which is 4, okay, all over 2. So I'm just going to go ahead and evaluate all of this right here. So I end up getting 50 times 2 times 23 is 46. And then 49 times 4 is 196. Okay, all over 2. So this ends up being 50 times 242 all over 2. So then when I go ahead and I multiply all of that stuff out, I get 6,050. So therefore, the theater will have 6,050 seats altogether. Okay, so we'll have maybe a total of 6,050 seats. Okay? All right, lastly, number 3, determine the sum of this information right here. So let's again identify what we know. We know t sub 1. Okay, we know that t sub 1 is negative 31. We also know d is negative 4 because it's going down by 4 every single time right here. Okay, but at this point in time, we don't know what n is. So I actually have to figure out what n is in order for me to be able to use either one of these formulas. So I'm going to use the explicit formula, which is t sub n equals t sub 1 plus n minus 1 times d to solve for n. I want to figure out how many terms there are. So I can take this negative 43 right here, and I know that t sub n is negative 403, excuse me. Because I don't know what n is, I can just say t sub n is negative 403. So what I'm going to plug in here is negative 403 is equal to, here I know t sub 1 is negative 31 plus n minus 1 times d, and here we know that the d is negative 4. So I'm going to distribute the negative 4 through, so I end up getting negative 403 equals negative 31. Negative 4 times n is negative 4n. Negative 4 times negative 1 is positive 4. So we get negative 403 is equal to negative 27 minus 4n. Now, in order to solve for n, we need to add 27 to both sides. So when I do that, I end up getting negative 376 equals negative 4n. Divide both sides by negative 4, and we end up getting n equals 94. So we know that there are 94 terms. So I can use either formula because for this one I need to know d, which I know, and for this one I need to know the last term, which I also know. So let's use this formula since we haven't used it yet. So I want to find the sum of the first 94 terms. So S of n is going to be S of 94, S sub 94. So this n right here is going to be 94. T sub 1 we know is negative 31. T sub n we know is negative 403. And that's all going to be all over 2. So I end up getting S sub 94 is equal to 94 times, when I do negative 31 minus 403, I get negative 434. Divide that by 2. So that means my sum will be negative 20,398 when I multiply these numbers together and then divide by 2. So that's what all these numbers will add up to. Now, the important thing that you need to get out of this video is that these are the sum formulas. And in order to figure it out, you need t sub 1, n. And then in this formula we need d, and in this formula we need t sub n, and then after that we just plug in all of our information to do some solving. Okay, that's it. Let me know if you have any questions. I hope you have a great day. Bye.